So, David King from Future Facilities, you've taken your expertise in computational fluid dynamics and applied it to a problem relating to fire prevention.
Yes, so we've taken our data center models that we've been doing for years, and in conjunction with a fire suppression company, Solar Fire, looked at whether it's possible to simulate inert gas discharge in a data center to understand whether the nozzles can be placed away from the IT equipment. The problem is that the noise created during the release of inert gas can have an impact on the hard drives inside the servers and storage equipment within the data center, causing a loss of service or a loss of data.
Mm-hmm. Yeah, and some big data centers have actually been taken out by this problem.
Yes, and there was an incident recently in Romania that made the front page of the BBC News website, so it's become a pretty public problem.
Right, but it turns out it's possible to have fire suppression without risking your data.
Yes, the problem is that the standards that are applied to data center fire suppression aren't data center standards, they are general fire suppression standards. So the standards require that you put nozzles in every independent zone, and that's it's not regulation, but it's something that is required. You have to meet the standards so people give you an insurance. And so what we did was, rather than adhere to the standards, we used the simulation to prove that the coverage of the gas is still provided with just having nozzles located in the floor void and in the hot aisle, so further away from the equipment and without a direct sound path. So reducing the risk of vibration and sound at the hard drives.
Right, and a simulation, obviously a lot cheaper than carrying out any sort of destructive test in a real data center.
Yes, well obviously the simulation is based in the computer, so you can run as many as you like, different variants. It's something that's quite tricky at the moment. This was really pushing the limits of what our CFD code could do, because the physics of the nozzle is quite complicated. The gas comes out faster than the speed of sound, which means that the physics of the gas is really quite complicated.
Yes, I mean, normal CFD, you're working on sort of hot air currents and thermal sort of induction and convection.
So we the airflow in a data center never really gets faster than about 5 to 10 meters a second. The gas comes out of the nozzle at 450 meters a second, which is roughly 1,000 miles an hour and about Mach 1.2. So obviously Mach number isn't something that we're really usually concerned with in the data center.
Great, but and as a result, does this mean that fire suppression companies, that data centers need to redesign the fire suppression products, or just how they're used?
Well, there are new fire suppression products on the market that try and deal with the noise issue by dampening down the sound from the nozzles. This is obviously rearranging the nozzle configuration is another option, and it may be possible that using simulation that this may feed back into data center specific fire suppression standards that people can then use to design new data center fire suppression systems.
Excellent, good work. Thank you very much.
Cheers.